And normal and small
same thing. What is the equation given in the refraction? Refraction. What is Snell's law?
The sine of angle of incidence to the sine of angle of refraction is a constant for current area that
See, he is very clever on notes. N1 sin theta 1 equal to N2 sin theta 2, right? N1 sin theta 1 equal to N2 sin theta 2. What is N1 and 2?
the different index of one
Medium 1.
medium.
What are theta 1, theta 2? Theta 1 is? Forgot, sorry? And below incidence. Theta 2 equal to angle of refraction, right? Angle of refraction. Theta 1 equal to angle of incidence. Theta 2 equal to angle of refraction. This is math. So have you understood that ray diagrams? How for the lenses. Lenses are governed by refraction, right? Lenses are governed by refraction. What are the two lenses? Mirrors are governed by reflection. Lenses are governed by reflection. So how do you draw ray diagram for the mirrors? Using the law of reflection. For the lenses, we use the law of reflection. For all this, you use the property of the ray propagation of the light. You say that light propagates in a straight line. Right? Straight line. Why the refraction happen? the particular medium. What is the speed of light in air?
3 into the 8.
3 into
Into the 8.
10⁴ meter per second. Yes. Thank you. Sorry. Review, what's the discussion you are making there? Physics only. So first, we read about this spherical mirrors, right? First, we started with the reflection of light, and then read about these spherical mirrors. Then there are two spherical mirrors. One is concave, other is convex. Then we use the law of reflection to draw the ray diagrams, and then we define the focal length. We define the center of curvature. Define the pole. Very good. Focal point. Focal point. Focal point. And then image formation by spherical mirrors. And the sign convention of the sign convention is same for mirrors as well as lenses. What is the sign convention?
That the object is placed to the left of the
Mirror or lens, the towards the pole. Yeah, pole is a reference, right? Pole is the origin. Towards the left, distance towards the left will be negative. Distance towards the right will be positive. So towards the upwards height, it will be positive. Towards down, it will be negative. So what is the mirror formula? 1 by f equal to 1 by u plus 1 by e. What is u? What is v? What is the u is the object distance? V is the image distance, right? What's the magnification formula? M equal to h dash by 8. Height of the image by, which is in turn equal to minus v by u. So f equal to r by 2, right? R equal to 2f. Is that right? 2f equal to r. F equal to r by 2. So let's say if you take this is a concave or convex. So let's say take this is the, okay. Sorry. Now here is the reflection is happening, right? And it towards inward. So this is the concave, right? Yeah. So this is inwardly reflection is happening, okay?
So the external this will be coming this way.
So this is a concave, right?
Okay. But the reflection is
Huh?
on this side.
Reflection will come towards the, let's say this is the pole, right? Let's say, okay. So if the ray is coming from infinity, so what will happen to this ray?
Then passes.
Hmm? It will again go because what is the angle of incidence here? Angle of incidence. Angle of incidence is measured with respect to normal, right? Angle of incidence is measured with respect to normal to the surface. Normal to where the ray is like ray is touching, right? So here the angle of incidence is with respect to normal. So it's a 0, right? So let's say if you consider it as a circle, okay, or sphere. So the normal will be towards the center. Let's say if you take this is the origin, okay. This is the center, okay. Then this is here. This is the normal. Here this is the normal. Here this is the normal. Here this is the normal. So for the circle, always normal will faces towards the center. Okay. For the circle, normal always faces, which joins that point to the center is that's a normal. So when you take this particular ray, then the normal is coinciding with the ray itself. So what is the angle? Angle of incidence will be 0, right? So then again angle of reflection will be 0. Okay. So one more thing. Let's say the ray is coming like this. Okay. So what is the angle of incidence here? This one, theta. It is with respect to normal, right? Here. Here at the point normal is this ray, okay. Then what is the where it will be reflected towards? So this one, right? Again theta. Theta again, so it will touch here. Okay. So if the ray is passing here, so this is theta, right? So again it will passes through this theta. So let's say ray is coming here. This is theta now. So this will be again theta. So if the ray is coming here, this is theta. Why that is theta? Because it is always measured with respect to normal. Angle of incidence or angle of reflection or angle of refraction, which is always measured with respect to the normal. Okay. So again theta will be this one. Same theta. Okay. So this is what all the points are touching here at F, which is called focal point. Focal point, right? From focal point to pole, the distance is called focal length, which is called F, small f. Okay. So this is the ray diagram for the concave. What about convex? Let's say this is for concave. Convex will be okay. This is not so clear, but assume that it is a convex. Okay, this is the convex. So what will happen to the ray here? So what is the normal here? It is perpendicular, right? So here theta is 0, so it will be reflected back in the same direction. What, Hari? Okay, here, okay, let's say ray is coming here. Okay. So what is the normal here? Can anyone draw? What is the normal? How to draw normal here? Vijay, how to draw normal here? What is the normal there?
It's actually diverges.
That's okay. I'm not asking diverging or converging. I'm asking to draw normal at that point. Come and draw here.
That should be extending.
Well, that line will be extended.
So we need to extend this line, take the center and connect the center to this point. Okay. And this will be normal theta. Okay. Then what will happen here again? It will diverge. That's why it is diverging based on the law of reflection. Angle of incidence equal to angle of reflection. Always theta is measured with respect to the normal. Okay. So what will happen to this ray? So if you extend this ray, it will touch here, right? So again, if you take again same. So again, you take this normal. So this is theta. Again, the ray will diverges, right? And if you touch this one, extend this one, it will come here. So this is virtually, this is the focal point. So here the formation of the image is real, right? The concave case. In the convex case, the formation of the image is virtual because the rays are diverging. The real rays are diverging, but when we extend them, we see at a point they are converging. So those are virtual. Image is virtual. Here the image is real. Okay. So did you understand the formation of this ray diagram of the concave and convex? Any doubt? Princy? So these are all with respect to that okay. These all diagrams are based on that reflection. Can you draw these diagrams, Hari? Huh? You don't have the book, huh? If you have the book, you will draw, copying. Huh? Can you come and draw on the board this one of the diagrams?
Okay.
You can draw. Can see? So based on same this reflection, you'll be able to draw. First, what you need to take the where the ray is touching the surface. There you need to draw the normal. How to draw the normal? How to draw the normal? Perpendicular. How to draw the normal? Rohit?
There should be
First, you need to fix the center point of the spherical mirror. Okay. Once you fix the center of the spherical mirror, then when you connect that center point to that surface point, if you extend that ray, that will be normal. Okay. Then the incidence will be with respect to the normal. The reflection also with respect to normal. Angle of incidence equal to angle of reflection. So these all mirrors are governed by this law of reflection.
Increase the temperature, sir.
Increase.
Increase or decrease?
Increase. So cold over here.
So cold, huh? You come and sit here. Huh?
Let it be later.
So you go through the uses of concave and convex mirrors, okay? What are the uses of concave, convex mirrors? So what is the mirror formula? Mirror formula is 1 by f equal to 1 by u plus 1 by v. Is it right?
Yes.
Hari? R is equal to 1 by v plus 1 by u. Which is right in both of them? Tell me one.
Sir,
Both of them. Which is right?
which is
First one or second one is right?
second what will be right?
You are not able to see it? Come and see it. Come to near and see.
Read it now.
Huh?
Read it.
You are not a teacher, you are a student. Do whatever.
Both are same.
Which is right? Both are same now. How Hari? One is 1 by u plus 1 by v. Other is 1 by v plus 1 by u. How both will be same?
First one, sir. 1 by u plus 1.
Eh? Which is right? Both of them. First one or second one? Sure? 100%? A plus B equal to B plus A or not equal to B plus A? Equal, huh? A plus B equal to B plus A, huh? Then these are same, no? 1 by U plus 1 by equal to 1 by B plus 1 by U. Confusing, huh? A plus B equal to B plus A, right? So both are same only, no? Both are right. 1 by U plus 1 by equal to 1 by B plus 1 by U. Okay. Let's solve one problem. Okay. Adida solunga. Example, okay. So it's a given convex mirror. Convex mirror used for rear view. An automobile has a radius of curvature 3 meters. What is given? Radius of curvature R equal to 3 meters. Sorry? Do you want me to read it again or what you are asking? That example 10.1. Okay, no need to see it. If you see it, just copy it. Example 10.1. Huh? I am asking example. Example. Example 10.1.
Convex mirror used for.
What is that example, madam? 9.1. Huh? Here 10.1 is there.
That's all version.
It is a new version, right? This is a new version. Yours is the old version. Huh? 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 What? Front page, what is there? Sorry, what is there? This is the correct one. That is the old one. Anyway, you found out the example, no? Here it's example 9.1, no? Here it's a 10.1. So convex mirror, it's given that radius of curvature is 3 meters. And if a bus is located at 5 meter, bus is located at 5 meter. So here what is U?
So use
5 or minus 5?
-5.
Here, right? Why you need to consider minus?
So because one is always
Because it is towards the left. That's why equal to minus 5. Clear? And find the position, nature, and size of the image. So what is F here? F equal to, sorry, R by 2 equal to, is it plus or minus?
So convex plus.
Plus, because
It's plus.
it's towards the right, right? So then F 1 by F equal to 1 by U, that's 1 by V. Formula is same, formula won't change, but you need to just change the sign convention. So now you need to find out 1 by V equal to 1 by F minus 1 by U. So then what is the V value finally you're getting, tell me? Renji, how many pages are there in your textbook? Tell me. How many pages are there? 2. This is so. I think that's a. This is 282 are there. I think that's a new one. That's a correct one. This is old one, Rohit. Okay, do it. This one. V. What is the V value finally? Hari, why we have taken here U minus 5, not plus 5?
So it's because it's on the left hand.
Very good. You are getting some. Getting some. What about F? F I consider plus 5 because for convex it will be converged towards the right. That's why F is positive. Okay. I think now getting LCM is getting difficult, right? Very difficult. Okay, anyway, do it.
10 and.
Yeah. That's a good way of doing. Do it. Multiply with 10, what will happen?
It's 10
The-
by
10 by 15.
plus 10 by 15.
10 by. Then it's 0.
So,
Do it. 10 by 15. Other one is 3 by 15. Finally, 13 by 15. Right?
One point
1 point. 13 by 15 is 13 by 15 is how 1.15. 15 by 13 is 1.1. Right? That is 1 by v, right? So you need to get v means you need to.
I put it denominator and
Upside and down.
denominator and
15 by 13 is so much. 15 by 13. So here v is, so v is positive means it's a real or virtual. V is positive means it's a virtual, right? V is positive means it's virtual. So what's the magnification? It's right or it's inverted? Right. So is it a smaller in size or it's a finally it's a smaller in size or it's a bigger enlarged? What is the magnification factor you're getting? Enlarged, huh? What's the magnification factor? Magnification factor is how much? It's greater than or less than 1? Greater than 1. Minus v by u is how much? 1.15 by 5 is how much? You can keep it like that, but just say it's greater than 1 or less than 1. 0.23, yeah? Oh, you're calculating so nicely. Huh? Diminished, right? It's less than 1, so. So clear this problem? Princy? Clear? All clear? Huh? 0.23. B equal to 1. M is equal to
This 0.2.
so image is virtual, diminished, and erected, right? Erect, diminished by factor 0.23. Okay. So now let's look at the concave. Okay, for concave, so it's given that object size is 4 centimeters. Size. So what is object size means? H. H, right? H is equal to 4 centimeters, and it is placed at 25 centimeter in front of the concave mirror. It's placed at 25 centimeters in front of a concave mirror. So what is 25 here? U. U is plus or minus here. Minus because it is towards the left, right? So then focal length is given as 15 centimeters. So for concave mirror, focal length is positive or negative? Why? It will be focused towards the left, right? So F will be plus minus 15. So F is minus 15, U is minus 25, H is equal to 4 centimeter. So you can find out V. Once you find out V, then by using H dash by H equal to minus V by U, you can find out H dash. They are asking to find out size of the image. So H dash by H equal to minus V by U. You know H, you know V, you know U. So you can find out H dash. Also, you can find out the nature of the image. So for concave, what is the nature of the image? Image is inverted and enlarged, real. Huh? Okay. Here, real. So what is the magnification factor I'm getting here is H dash equal to minus 6. H is equal to 4, right? So it will be enlarged because height of the image is more than height of the object. That's why it is enlarged. So this is about reflection. Sorry? What's the doubt?
What are the data?
Sorry?
What are the data?
What is the?
What are the data?
F is equal to minus 15, U equal to minus 25, H equal to. So V is getting as minus, so it says that image is real, inverted, enlarged. How will say it is a erect or inverted? How can we say it's an inverted or erect or inverted? Depending on the mirror, right? But the concave it is. No, I'm asking erect or inverted. For concave, inverted. Convex. For concave it is virtual. Concave it is real. Convex, virtual. So magnification factor you need to find out once you get the B and U, or size of the object or size of the image, right? Clear, Vijay? Clear, right? How to sign conventions are clear? Sign conventions. Concave and convex. Okay, that you calculated the. Okay, let's go for reflection. You do calculations at home. Refraction. So let's say you take a glass slab. So what is the glass slab refraction index? It's a denser medium, right? And if you see it, it is from the table. Can you say what is the refractive index value? There is a table, no? For glass slab, it's a from 1.5 is it? So let's take it's a here medium is air, yeah. Here it is glass, okay. Again it is coming to air. So here this is the air glass medium interface. Here glass to air medium interface. So let's say if you take light rays coming like this, okay. Light rays, let's say entering like this, right? Sorry. So how to draw the normal here? Normal will be just perpendicular to this one. Okay. This is the normal. So what is the angle of incidence here? This is theta I. Okay. So here we are considering glass. So fully transparent. So let's consider there won't be any reflection. So now what will happen? It will bend towards the. So then theta R will be less than theta I. Is that right? Bending towards the normal means theta R must be less than theta I. Yeah. So let's take this. This is theta R. Okay. This is theta R. Now again you need to consider here normal. So here what is theta I? At this point, theta I will be this. Okay. Now it is entering from denser to rarer. So it should go away. So if you consider theta here, this theta R will be greater than theta. Okay. So this is about the refraction. So Snell's refractive index is defined as n is equal to neta here it's given as neta. Okay, n only or neta n equal to c by b. C is the speed of light in air by in that medium. So let's say if it's given that n equal to 1.5 1.53. What is the medium then? Okay, 1 equal to 1.53. 1.52 per glass, right? So then we'll find out the speed of the light in the medium. Speed of light in that glass medium. What is the speed of the light in the glass medium? Speed of the light in the glass medium. Low. N is given, right? C is already known, right? So I'm just asking to find out B. I'm not saying low or high. N equal to C by V, B equal to C by N. 8 by 1.52. It will be approximately 1.5 into 10 power 8. Approximately. So what is Snell's law? Snell's law. Snell's law is not there in the book. Huh? So it is given by n1 sin theta 1 equal to n2 sin theta 2. Or n1 sin theta I equal to n2 sin theta r. Theta I is angle of incidence. Theta r is angle of refraction. N1 is refractive index of the medium 1. N2 is refractive index of the medium 2. So here solve one problem. Okay, it is given that angle of incidence is equal to 45 degrees. Theta is equal to, given that angle of incidence equal to 45 degrees. Okay, theta I equal to 45 degrees, and light is entering from air to glass. Light is entering from air to glass. Air to air medium to glass medium. Okay. So the refractive index of the glass medium is 1 point. Now find out the theta r. What is angle of refraction? R must be 45. Theta equal to theta r. Huh? Theta r must be less than or equal to theta I, right? Because it's going from rarer to denser. Find out theta r value. How to find out? Using Snell's law. What happened?
It's not there.
So here in n1 sin theta 1 equal to n2 sin theta 2, what is n1 in this case? Viji, what is n1 in this case? It is going from air to glass, right? So n1 will be 1. It is going from air, right? N2 will be 1.52. Theta I is already given as 45 degrees. So you need to find out theta R. Okay. So 1 into sin theta 1 equal to how much? Sin 45 is how much? Sin 45 is very difficult, right? 9th class sin 45 is not there, huh? 9th class you don't have trigonometry, yeah? You don't have, huh? You don't have, huh? Okay. Okay, sin 45 is 1 by root 2. Okay. And N2 is 1.52. Sin theta 2. Sin theta 2 equal to 1 by root 2 into 1.52. Theta 2 equal to sin inverse of 1.5. Okay, when the trigonometry comes, I'll teach. Okay, what is sin inverse, how sin theta, sin 45 is equal to 1 by root 2. Okay. So let's say consider the what are the two spherical lenses? Concave and convex. So let's consider convex. Convex. This is what? Convex lens. Okay. Even though it is not a convex, but consider it is a convex. Consider it's a. So this is the region. So let's say if a ray is entering like this, what will happen? Refraction. What is angle of incidence here? 0. So it will go, it won't bend because 0. Okay. We consider n1 sin theta 1 equal to n2 sin theta 2, sin 0 equal to 0. Then again refraction also will be, it won't bend. So when you take a ray like this, okay. So what will happen? It will bend towards the, finally it touches the focal point. So again, this is called focal. From here to here, the distance is focal length. So here again, this is R. R equal to 2F. C. Center of curvature. This is distance is R. Okay. So here the sign convention is again same. Finally, let's solve one problem and let's close for today. Right? Okay, only one problem only. So what is the here length formula? 1 by U. 1 by V minus 1 by U. So it's a concave lens is given, okay? Here concave lens is given. So I'm not asking you to solve it, just tell me the sign convention, okay? I'm not asking you to solve the entire problem. Concave lens, okay? Focal length is 15 centimeters. 15. For concave it is a positive or negative? For concave lens, it's a negative. And image distance is given as 10 centimeters. It's a positive or negative? Negative. image distance is negative. So then 1 by f will be 1 by u minus 1 by v. So you can find out u, right? So once you find out u, so what is the magnification factor here? Here v by u. For the lenses, for the mirrors it is minus v by u. For the lenses it is v by u. Then, so like that you can find out. So okay. Yeah, please. So what about for the is a convex lens focal length is positive. Object distance is always negative. Image distance is positive. What is the power of lens? P is equal to 1 by f. So what is the measure it? It's measured in diopters, right? Diopters. 1 diopter equal to meter inverse. Is it right? Diopter equal to meter inverse. 1 meter inverse. Yeah, this is the old one. From here, right? Tomorrow we will come back.